Sir, voice is not audible, sir.
Is all right now? No problem.
Yes, sir.
Yeah, it was during the 12th century. See, if we look at the history of robots, okay, from 12th century onwards, in fact, people started imagining things like golem, a kind of a clay statue. Okay, so and then this just young Rosum, okay, he has in fact coined the word robot. Okay. In fact, he has come up with a kind of a movie about the robots in the 12th century. So just I would like to give a brief overview. It was a nice kind of introduction for this. So look at this. There are three laws of robot. A robot may not injure a human being or through inaction allow a human being to come to harm. Okay, so this is number one. These laws, in fact, were framed by Isaac Asimov. Do you know this guy? Isaac Asimov, anyone from the class? He's a very famous scientific fiction writer. Fiction writer. So, famous writer. He has written a lot of popular science books also. He is very famous. And he, in fact, has framed three laws, in fact, which is widely been accepted. May not injure a human being or through inaction allow a human being to come to harm. A robot must obey the orders given to it by human beings, except where such orders would conflict with the first law. A robot must protect its own existence, except where such protection would conflict with the first or second law. So these are some of the three main laws of robots. Okay, so let's say robot laws. Now, if you look at the definition of a robot is a machine that can be programmed to perform different tasks. Is an intelligent connection between perception and action. How do you visualize it? Robot is a machine that can be programmed to perform different tasks. What do you really mean by it? Imagine a kind of a robot we have, a wheeled robot. So you need to program it in such a fashion that it can take on different routes, okay, a kind of a paths. So at every point in time, the robot has to sense the environment. That you call it as a perception. So you can have laser range finders, or you can have camera. It's very powerful nowadays. Now they call it as visual slam is an area nowadays picking up. Visual slam. Just type in Google what is slam, you come to know. It is an important area. It's called a simultaneous localization and mapping. Okay, simultaneous localization and mapping. So visual slam means the robot has to simultaneously localize as well as map the environment using camera sensor. Okay, that's the visual slam they call it. So there should be an intelligent connection, because when you take some camera pixels of images about the surrounding environment, what do you infer from that particular image is very important. This kind of information are crucial for robot to navigate. Okay, the robot, in order to navigate in an environment, it should have appropriate information. So the information is a key. So based on the information, what are you going to infer from that information, and what kind of decisions you are going to take? Decisions the robot are going to take. Understand the point clearly what I'm saying? So when you visually perceive the environment, you got some information. From the information, what you are going to infer, and based on the inference, you are going to take some decisions. Okay, that's very important. So these decisions it should be an intelligent decision. So if the robot is going to work with some kind of data, okay. So for example, if we're going to have a robot which is going to receive some sensing information, and based on that it acts immediately. They have told you. I hope you can recall that. This kind of robots are not very intelligent. Why? Why it is not intelligent? It sends and acts in a very, what do you call, in a very immediate mode, without of much thinking, deeper thinking, planning. Without much deeper planning, it's going to act. So in that case, it will be a problem for you. Okay. So naturally, it's important for you to design robots which can take intelligent decisions. So that's where the entire artificial intelligence domain is coming into picture. It can help machines to take intelligent decisions used based on some kind of planning. Okay, so that's important. So it's not only okay; it has to perceive and then take actions. It takes action through its kind of actuators. Actuators can be for wheeled robots. It can be wheeled robot. It can be the motors connected to the. Yes, that's important. So the other way you can look at it is kind of robotics can be called as a design, production, control, and programming of robots. Okay? So application of robots to task solving, specific task. Okay? The robots can solve some specific task like welding, painting. Okay, sorry, it can even do operations like pick and place objects. Okay, it can move around, it can fly, it can go underwater, all kinds of specific tasks. So the analysis of control tasks, sensors, actuators, and algorithms in humans, animals, and machines. That's another way of looking at robots. Application of the above to design and application of robots. Okay, so all these three coupled together, you can apply it for the design of robots. These are all different ways of looking at the definition of robots. My point is, you look at this particular definition. Okay, very interesting. Based on perception, okay, the actions you have to take intelligently connected perceptions and actions. You perceive the environment and take some intelligent actions. That's the kind of robot we are talking about. Okay, so now, so the definition is a physically embodied, artificially intelligent device with sensing and actuation. Okay, so what's the key takeaway point from this slide? From this slide, previous slide, key takeaway point. Which one you prefer? If you have some takeaway points from this slide, which one you prefer?
Sir, it should be able to take in input, through perception,
Yeah.
act on it using actuators, have some
Okay.
sense of intelligence in order to, after getting the perception, it has to understand what is it,
Yeah.
what is exactly there in the environment, and
Yeah.
based
Yeah.
upon that, it should act using
Yeah.
actuators.
Yeah.
And that's it, sir.
Yeah. So that there is something called visual slam. Also, you keep thinking. Okay, this is an area really coming up. Okay, visual slam, okay, particularly for mobile robots, because cameras nowadays the prices are coming down. Okay, so you get some very powerful cameras, and you can fit over systems. Okay, and you can get a very good learning algorithms. Okay, like AI, machine learning, deep learning algorithms, which can help you to get features and get some inferences about the surrounding environment. So robots connected with camera with what you call computer vision is a real uh, what you call really happening domain. Okay, something really happening, and something is really changing the world. Okay, so this is something we can think of. So computer vision, AI, deep learning with robots. That's what the message. Okay, so it must think to connect sensing and acting. So the question before you is washing machine a robot? It is okay. It is a kind of a small kind of a robot without a much intelligent planning at all. But it is sensing, actuation, and processing is there. Okay, so it's more like a simple consumer appliance, but it's having some of the components of the robots. Okay, it's a complete consumer some appliance, but okay, but it can be called as a mini-level kind of machine. Okay, why are people interested in robots? We like to compare our abilities with okay, and ability span, and by means of repetition to penetrate into laws of nature. We intend to produce a perfect helper with abilities comparable to ours and who might be even more reliable than humans. These are some things that you can ponder upon. Okay. Think about this. Okay. So always we have that deeper inner kind of desire, a perfect helper to do menial jobs, okay, as well as to do repetitive jobs, dull jobs, which may not be interested in doing, okay, and who may even be more reliable than human beings. Okay. How far our creativity span, limits of repetition to penetrate into laws of nature is something also quite important. Okay. So with the kind of computing power what we have, we can crunch a huge amount of data, big data they call it. And with this big data, with the number crunching, we are now in the process of thinking of penetrating, okay, penetrating into deeply into the laws of nature and all, particularly the field of quantum computing. Okay, all these are coming up, which can help us to crunch more numbers in much more faster way. Okay, in fact, when I heard of DNA sequencing during 1990s, people said it takes years to complete the job. DNA sequencing. Every human being's genome, na, it can be sequenced perfectly. Human being's genome. So nowadays people are doing it in much faster time limit, and we are in the process of coming up with a kind of more kind of a database of all human beings' genomic collections, okay, DNA sequencing, which we are doing it because of the power of computation. So when the power of computing, yeah.
Sorry, sir. One doubt, sir.
Yeah.
Sir, what is DNA sequencing?
No, see, we have genetic coding now. In our body, we have the genes. Okay, so these genes can be coded. For everyone, we have our own unique way of genes. Okay, this can be coded means we can identify this what you call pattern in our body, the genes pattern. Once you identify this pattern, then it is easy for us to what you call predict our diseases, what will happen to us in the long run, whether we'll get cancer or not. All this can be predicted. Okay, so we have millions and millions of this kind of what do you call genetic this kind of what I say gene coding. Okay? They are coded in the form of this kind of DNA sequence. So this sequence has to be properly decoded in order to understand our own code clearly. Okay, so that's what people are doing with computers. They are trying to do it now. And are you getting the point? What I'm saying? If you want more
Yes,
details,
sir.
you can
Yes, sir.
type in Google.
Understood.
Yeah, Google. You type in Google, you get more details. But the point is, this is happening primarily because of huge number of millions of data. Okay, you have millions of data getting processed. Okay, that's what we are doing with the help of powerful computers. So naturally, even for better perception about the environment and then planning for robots, everything can be done with long-range kind of planning can be done with the help of huge amount of data, and the robot can plan, optimize anything it can do with the help of powerful computing strategies. Okay, so that's what I would like to convey here. Okay. So the major subsystems in any robot, you know that very well. There is a kind of mechanical elements are there, electrical systems are there, control is playing an important role, and power sources are there. So when you are thinking of cognitive robots, okay, the robots which can think and then plan, okay, and all these, the powerful sensors are important, like camera sensors, okay, and powerful actuators. People are nowadays going for MEMS-based actuators. MEMS is micro electromechanical systems, okay. So when you are going for some miniaturized version of robots, okay, mini robots, small robots, you can go for this kind of technology. Maybe wherein motors can be very small size, extremely small size motors with a lot of torque. Okay, so you can create such kind of powerful small machines which can perform a lot of tasks. Okay, in a what do you call in a SWAM mode. Have you heard of this vertical SWAM technology? Anybody from the class? So this is another domain. Okay, cooperative robots. Then you call it as multi-robot systems. These are all coming up. When we have small group of robots, okay, small flying robots or small wheeled robots, they'll work in a what you call coordinated manner. They call it as multi-robot systems. Multi-robot systems. This kind of cooperative behaviors are, in fact, inspired from animals. Okay? Inspired from animals, biological systems. So these systems are of like bees, honeybees. Then we have what do you call birds. Okay? A flock of birds, they move together. You might have seen it in the sky. Okay, they move towards a destination. Yeah, a flock. A flock means a group of birds, and they move in a particular fashion that they will optimally utilize their energy. Long distance they will travel. Okay, optimally they utilize the energy. They follow a particular path, and they reach the final destination. Okay, so these kind of biological behaviors can be, you get inspired because of that, and you can develop algorithms, and you can create hardware devices, okay, with the help of micro electromechanical systems, and you can achieve something. So what's the point I'm trying to convey? Can somebody repeat what I said? It's an important point. Another happening domain. What is that I said? Anybody from the class?
Sir, about we are asking about from this slide what we are what is the takeaway?
What is your takeaway? Yeah.
So basically, when we came to cognitive modeling, cognitive robots, there are different under them. There are different happening technologies right now. Like for example, starting with basically swarm. Before that, actually, what is microelectromechanics? Using MEMS, we can even develop small miniaturized
miniature
motors. And sir, can I share one thing on this? A swarm.
Yeah, please. Yeah.
I've seen a video, sir, an experiment from a university, foreign university, where they are using a small, it's actually a very small miniaturely actuated robot, very small. I think Festo, there is a company.
Yeah, I know.
Festo. So Festo, they have developed a small ant.
Okay.
Studying ant well, they have made a small ant using MEMS technology that basically uses nothing but a flap mechanism. I mean, it's a elastic flap, passively actuated.
Okay.
So it is passively actuated one. So a group of those things are made, and using some communication technology, they are all like real ants. They are tried to program it on in their lab. So how an ants work and how they fetch food and all those things.
Oh, excellent. Okay, so they, in fact, in ants, they release a particular chemical. It's called ants colony algorithm. You might have heard of it. You heard of this term? Ants colony algorithm?
Ants colony
algorithm, yeah. In fact, ants, they follow a specific path. In fact, if there is a food somewhere, so the ants, they move in groups. Okay, they move in groups like this, and they release certain chemicals. Yes. And the ants which are following a particular ant, they sense this chemical and they take that particular route towards food. Okay, once one particular ant reaches that food, the path it has traveled, there will be that trace of chemicals. Okay. So the rest of the ants
like laying a map for other ants.
It's more like a map for the other ants to reach the food. Okay, that kind of algorithm they call it as ants colony algorithm. Okay, so it's a very powerful optimization tool they employ for many path planning applications of robots. These are biologically inspired. Cognitive robot, most of the ideas, okay, we are looking at animals and human beings very closely, and then we build algorithms. Okay, particularly if you take the ML technology, which in fact is right now is the buzzword, deep learning ML. All these ideas stems from our neuronal, biological neurons, okay, by brain, how they are working now. Particularly the vision system, how it works in human beings. They have copied and they worked on something called deep learning. They call it as convolutional net. Okay, it's a very powerful idea. Anybody from the class heard of this? Convolutional network. We'll be learning in third semester. But these are very powerful networks, but it's based on the idea of our human brain, the cortex position of our brain. Okay, so how it perceives information through eyes, and how it segregates information into different patterns, and how we are processing that information in the brain. Based on that, we have developed a very powerful algorithms, which in fact is right now ruling the computer vision world. In the past 5 years, if you look at the computer vision world, this particular technology, deep learning technology, is completely changing the status quo. Okay, status quo is completely the conventional way of approaching image processing is now changing. So that's why we introduce this subject for you guys. Third semester, you will be learning this thoroughly with a lab also. So this one technology will be there for another 15 years minimum. Okay, people cannot refute that computer vision technology. Okay, so that's something you should think of. Then in cognitive mode, then see even when you talk about micro electromechanical systems, you can also think of nano level systems also. We have a very powerful nano laboratories in our university, SASTRA. Nano team is very powerful. Okay, these guys, they are scientists particularly, they are coming up with a lot of very good publications. Maybe nano level kind of actuator designs and all. Maybe you can think of those guys who are interested in mechanical design. I want to design some new motor or something like that. If you are interested in it, maybe you can approach nano people to come up with some new kind of design, motor design and all. That will be really appreciated also. Okay, so you can think about it. Nano motors. Okay. So the various approaches to robotics. Okay, so we can think in terms of the theoretical part, okay, theory. So then experimental robots are there. Okay, you have to check principles, build toy devices. Cybernetics is another area you can think of, wherein you can think of communication, control, and processing coming together. Signal processing. Artificial intelligence, combination of various engineering disciplines combining together records experimental robotics. Industrial robots are also really, this domain is coming up. Okay, many of the manufacturing industries nowadays they are into robots. They are buying this robotic components. Okay, and so all these fields: control, instrumentation, electronics, machine engineering, production automation, everything coupled together. Okay, so there are other kinds of robots also. Like here, I can say one important point. Maybe you can look into Springer Handbook of Robots. It's a very good book. In fact, it's available in our library. Maybe once you come here, maybe you can go through Springer Handbook of Robots. You can see very huge the application areas. You can get a feel of it. Kind of applications like agriculture, medicine, biomedical, aerial robots, okay, various applications, mining, okay. So everything will come to know how we are employing this kind of robots for various applications from this book. It's an excellent book, Springer Handbook of Robotics. Maybe you can refer to once you come over here. It's available in the library, okay. You can refer to that. You'll get a clear picture of various kinds of applications we can do. Very unconventional, conventional, everything you can see. Okay, the kind of applications. So that's a point here. Okay. So then I can think of industrial robots like this. Say industrial robotics of yesterday during 1950s. Okay. So this kind of robots were there. So nowadays you can think of robots like human beings, like robots. You can play. You can do what you call service. They call the service robots. You can help elderly people. Okay. You can take care of elderly people. So this particular wheelchair, in fact, can you recall the guy who used this kind of wheelchair?
Yes, sir.
Stephen Hawkins.
Yeah, Stephen Hawkins. Okay, this is a kind of robots we're talking, playing robots. Okay, so this kind of very powerful cooperative strategies are employed, algorithms. There is a field called as game theory. Have you heard of this? Anybody from the class? There are two aspects here I would like to mention. One is the game theory, another one is the deep reinforcement learning. These two technologies are heavily employed Heard of these two technologies? Anybody from the class would like to comment on it?
Sir, in my undergraduate
Ah,
classes,
yeah,
about game theory, my teacher has told one point
yeah,
to us.
yeah,
Uh,
yeah,
we play nowadays, most of the students, we can find them playing this PUBG and most of the advanced games, not only PUBG,
yeah,
like,
yeah, yeah, yeah,
for example, this Tomb Raider, Counter Strike, all those things. There,
yeah.
when they are playing, the situation, the environment, and as per their gaming style, whenever a new situation comes in a game,
Mm.
there the suppose if I am the a person who is playing that game and
Okay,
I am having a certain methodology to play that game,
okay,
according to my methodology, the next game will be actually adapting to my style
okay,
unknowingly. And I mean,
okay.
I may not observe it, but
Mm.
actually behind the program this will
Mm.
be happening, adapting to
Okay,
my style. And when we are in a multiplayer environment, what
okay,
happens is that my game style will be affecting someone else's game style because they are totally different.
okay,
So that's how the strategy of one person is being employed in a whole game.
okay, okay.
Different strategies simultaneously. Even their game is being developed. I mean, their computer will be learning.
Mm.
Human versus computer. When there is a round, computer will act just the opposite way of how a human used to play.
Yeah, yeah, yeah. Excellent. That is more of whatever you have said is more of reinforcement learning techniques. Okay,
Okay.
so based on a particular strategy, okay, that you have employed, the network learns whether it is a kind of an advantageous one or a disadvantageous one. Based on some cost function, it will observe that. So whenever advantageous moves are coming, it will try to learn it through something called a reward. When it disadvantageous position it takes, it will be more like a punishment. It will take like that. They call it as a reward and punishment approach. Reward and punishment. But the key point that you have to understand here is these kinds of robots, okay, the machines which learns through machine learning techniques called reinforcement learning method. Under the machine learning, we have different learning techniques. One you call it as a supervised mode of learning. Another one you call it as unsupervised mode of learning. The third one you call it as the reinforcement learning. Okay, unsupervised, the classic case is deep learning nowadays is coming under unsupervised. You can also train deep learning with supervised mode also, but deep learning with unsupervised mode is gaining more momentum. But reinforcement learning is a lot of applications are there for robotics. I would like to stress this point here. Okay, because if you look at the top universities in the world, particularly CMU, okay, and other universities, Carnegie Mellon, Georgia Tech, and other famous, world famous universities. Even in India, you can take IITM. Okay, they are doing some fantastic work on deep learning based reinforcement learning for robotics application. And maybe you can visit Professor um, Balram Ravinder, okay, from IITM. Okay, he is doing a fabulous job in the field of reinforcement learning applications for robotics. Okay, this IITM group is really doing fantastic job in many areas, particularly deep learning also. Those who are interested in deep learning can refer to IITM group. Okay, one Professor Nitish Kapra is delivering a fantastic work. Okay, I have learned many things from him. Okay, Nitish Kapra on deep learning. Okay, I have attended some of his courses, some fantastic courses testing. So Balram Ravinder for reinforcement learning and Nitish Kapra you can refer to. But the point what I would like to convey here is for robotics, these two technologies, deep learning and reinforcement learning, can be employed in a uh, very powerful way, which can enhance the machine's capacity to do some strategic decisions. Okay, so that's number one. So the deep reinforcement learning, how it works is more like this. As somebody, Ramarao said, who said it? Ramarao, you only said it.
Yes, sir. Vijay, sir.
Yeah, Gopal Rao, Vijay Gopal Rao. Vijay Gopal Rao, the deep learning, reinforcement learning, the power comes from because of simulations. Okay. So, for example, a human being can play at the most some around 10,000 games of chess in his entire lifetime. But machines can play these 10,000 games in a simulated mode, okay, okay, within 2 hours. So what happens is the machine learns from this kind of data and decisions it has made, okay, in a very powerful way. Okay. So that's why this reinforcement learning is something we should think of, because the computing power is now increasing like anything. We can perform high power simulations in a matter of a few hours, seconds, okay, minutes and seconds. So naturally, the machine will learn in a much faster way than a human being learns. Which in fact, it takes an entire lifetime for a human being to learn something. It will learn in hours. So that's the power. That's why people are afraid of AI technology. Okay. In fact, you may be knowing Elon Musk. You just type Elon Musk, and he has given a lot of statements about the dangerous uh, potential of AI technology. Particularly, he is afraid of this reinforcement and technology, where machines can learn things in much faster way than human beings can, okay, and thereby they can start seeing world in a different way. Maybe we will be seeing the kind of a world which in fact it may take some around 5 lakhs years for us, okay, to see the world and its natural laws in a particular fashion. The machines can do it in few days. Okay, that's a possibility he's envisaging. So that's something we need to be a little bothered about. Okay, so they can see things in a different way, they can plan, they can strategize, and we don't know, okay, what will happen. But there is a potentially we need to go back to the laws. Okay, the robot must obey the orders, otherwise it may leads to complete anarchy or chaos. Okay, so we should be careful about this in particular. In this regard, I would like you to see this movie I Robot. It's a classic. How many of you seen this movie in the class? It talks
I've
about
seen,
it.
sir.
Yeah,
Yes, sir, I've seen, sir.
can you tell that theme of it? I Robot. What's the theme? It's a rogue robot, na? Robot becomes a rogue, a rebel. Okay. So it forms its own team and it starts controlling people. At one point of time, it kills the person who has, uh, in fact, who had controlled it. Okay. All these things happen, hangama. It's a very interesting movie. How robots becomes rogue robots. Okay. That's something to watch. That's yeah. So the industrial robots, the following abilities are important: manipulation abilities, autonomous performance, program can be modified, very flexible. Yeah. Okay. You might have seen it. There are manually operated cranes. Okay. These cranes are manually operated. You cannot. There won't be much dexterity. But an industrial manipulated robot, you can program it and you can make it very flexible with high degrees of freedom. Okay, it can rotate and it can do a lot of activities. We'll see some videos in next class. I'll show you some videos. But just get a feel of it. Okay. In universality, there should be feedbacks, to be concentrated in the space. Universality here we'll be talking about compatibility. Okay, so you can buy one robot from one vendor and then you can load it with some other software. And still there will be kind of compatibility issues will not be there. Okay, that kind of common standards they are bringing now. Common standards. Okay, so that it's more of user friendly. When there are common standards, anybody can utilize it and use it to the level, full level they can utilize it, potentialities. Okay, and think about it. So this kind of cooperative industrial robots are also there. You can see their car manufacturing, some machine or car manufacturing robots. So you can just visit just Tesla in the Google, Tesla robot car manufacturing plant. You will come to see some excellent videos were there. Tesla car, you know that? Anybody from the class? What is Tesla?
Yes, sir.
It's
Yeah.
an electric vehicle.
Yes, sir.
Elon Musk as his brainchild. It's Elon Musk brainchild, and he has come up with a factory, the completely controlled by robots. You can see that YouTube. Very interesting. Okay, how he has created the plant. In fact, 15 years back he created it. Okay, when everybody said it is not going to work. He said it will work until he made profit out of it. The plant, Tesla car. When the Tesla came into picture by 2009, 10, I think. Nobody was really confident. But nowadays they are making some profit. Okay, gradually they are invading the world market. And the plant is completely important for us. The plant is completely automated with only robot controlling everything, manufacturing the entire plant. I think Tesla and this Elon Musk is in fact a kind of a visionary. Maybe you can see some of his website. He's a visionary technocrat, but extremely, what do you call, super confident. Sometimes he may fail also, but my point is he will take human beings to the next level. So that's the key. Okay, sometimes he may fail also. That's always there. So these visionaries sometimes they fail miserably also. But the point is, there is a possibility. Okay, there is a possibility of human beings reaching the next stage because of this kind of people. Okay, next stage of evolution. So he's now right now thinking something very big way, like taking human beings to what do you call SpaceX. You know, the SpaceX program is talking about taking human beings to space. You can spend some money and you can stay in some nearby planets. All this he's thinking. He is thinking also of tunnels. Okay, instead of roads in the surface, we can create tunnels under the earth and we can do transportation. Okay, that is something another area is really concentrating. Okay, sea transportation also is thinking of. Okay, so all these are happening. Is all and he is not only is thinking, he is trying to generate funds. That's important. He generates funds and he tries to implement it also. A very powerful person, Elon Musk. Maybe you can type in Google and see. Those people who are not aware of it, we get some inspiration. So production and automation is another area. You can think of robots heavily employed. Okay. So we want to decrease the human presence. This is another problem we have. Human beings are, if you look at human beings, we are evolving. Okay. More and more people nowadays, they are disinterested in doing dull jobs, repetitive jobs. We want as more creative, more kind of fun-filled job. Okay, we don't want to do some repetitive jobs for hours together. So, particularly in Western world, they are facing a huge shortage of people who wants to huge shortage of people to work in this kind of dull, repetitive jobs. So naturally, they would like to rely on only robots. So many of the top industries in Western world, they are moving towards robots. Primarily, the reason is this. Human beings, they are getting educated nowadays, particularly welfare states like European countries. They get top quality education. Once they get educated, they don't want to do this kind of menial jobs. They would like to read literature, listen to music, travel around. Okay, they don't want to sit and do this kind of a job. So naturally, this is a problem. Okay, so shortening the production time, another one, optimization problem. Okay, the robots can do the job for hours together without any complaint. So you can do that. You can get more production. Okay, is there an advantage in it? More production, more and more will produce. Is there advantages? We don't know. Okay, so more and more you produce, what's going to be the end result? We don't know. Okay, but things are happening in that fashion. So increase of performance and productivity of labor, that is another thing. Whether it's advantages. It's advantageous for the developed countries. For developing country, it will be a problem. Okay, so you have to understand it. So human beings here, they are looking for a job, but the robots are going to take up the job, and it will be a big problem in the coming century. Okay, particularly coming decade, in fact, 2020 to 2030, maybe you can refer to. There is a book titled "Average is Over." Google it, see some of the pages, please. Get a feel of it. Average is over. Can you guess what will be this topic here? This book? Any idea?
Sir, is it like the current lifestyle, comparing the current lifestyle of a human being to the future lifestyle
Yeah,
based
that's
on
right.
work and
That's right.
productivity.
But that's right. But what is this average zone? What do you mean by average?
Is it the author's point of view that this particular moment, what we are having, is average and that is going to be done completely, replaced completely? Is it the point, sir?
It's more like that. But the point is, what they are saying is, human beings, they are completely going to rely on highly automated systems in the near future. Okay? So naturally, there are huge chunk of jobs, in between jobs, intermediate jobs they call it. These intermediate jobs are going to get completely wiped out. Okay? Particularly you might have autonomous cars. Huh? Autonomous car is an area you can think of. Autonomous cars, they are more like mobile robots. So these autonomous cars, once it comes into picture, the job of a driver is going to get completely lost. Okay. Likewise, code building algorithms, AI algorithms, code building, particularly as I mentioned, simulation-based, reinforcement learning approach-based code developers. So you're going to enter into the market. The middle-level programmers' jobs, that's going to get wiped out. So who will survive in the market? Can you guess? They're going to be only people with some level of intelligence. Okay? That too, IQ level, a very high IQ level, who can build this kind of systems. They will get some job. So the middle level people, the average people, okay, with some level of IQ, those people who have got opportunities in the field of ordinary programming, some basic level programming, okay, some people with some talents related to, some skills related to operating systems, machines and all. Everything is now going to get usurped by these robots. Usurped by robots and automation technology. These jobs, you know the word usurped. Usurped means grabbed. It's getting grabbed from us, grabbed by robots and automation technologies. Okay, robots, automation. So naturally, people with those who are not clearly proficient in their area of interest, those who are not proficient, they will not get a job at all in the another 20 years down the line. So, but people with extraordinary talents and skills, okay, in building these kind of systems in a very innovative way, they will definitely find a job, but with a huge salary. So, what will happen? Can you guess what will happen because of that? The long run?
The economic will be crushed.
Yeah, that is one thing. But another thing is the gap between haves and have-nots going to widen like anything. Okay, there will be a super rich people one end. There will be more like slaves who depend on these people for everything will be created in the near future. And the machines will rule the entire world, okay, with the help of the super rich people. Because they control these machines. Okay. So these have not, the slaves will suffer. So naturally, only service-related industries will be there because people like see nowadays I'm seeing that already. Even people with BTech qualification, they are into a lot of service-related jobs. Particularly, I'm seeing people travel by bike to deliver food. Okay, so and then a lot of what do you call it? Personal caretaking uh, jobs they are into. Okay, so many well-educated people they are into this kind of jobs primarily because they can get only money from this. These high-end jobs are getting completely moving away from them because they are average. That's the only thing. Because the average knowledge is not really going to help us in the long run. It's a problem we are going to face. So that's why we need to be much more proficient. But we cannot compete. We cannot keep running behind all this. But what I'm saying is, when you learn something, learn it in a very thorough, professional way. If it is within our reach, maybe we'll reach. If it is not within our reach, maybe you have to think something alternative. Okay. So that we should be very clear about. So technical, economic, and social viewpoint. That's what this is one social viewpoint I said right now. Okay. Automation decreases the influence of the human factor to the quality of production. Decreases, okay, influence of human factor. So that's a problem. In fact, we are no more wanted. A huge chunk of people, just imagine, you are simply saying that you are not wanted. What they'll do? It's become a very big social problem. You need to imagine that. And the qualification structure of the workforce has changed. The number of workers decreases, which influences the unemployment. That's what I told. Key point. Okay. Think about it, how we can avoid it. But we can create more robots for elderly care. That and all is there. Health benefits. Okay. You might have heard of surgical robots. Surgical robots are becoming surgical robots coupled with virtual reality and augmented reality. It's another area really coming up. A surgeon can feel how the blade will go inside go inside the body of a patient. Okay? He can see deeply with the help of what you call MRI and all kinds of scanning and all. An image will be created for him. The videos will be there. He can use that images, the sensors, okay, the noise, everything, the blood flow, everything he can feel, and he can take appropriate corrective decision making with the help of surgical robots. So surgeons they can do, or otherwise they can completely autonomous also is there. Okay, but these are all some areas quite useful for human beings. They can do highly precision operation. Normally human beings they commit error. Okay, doctors that too. Okay, there is a possibility. Always there is always a probability of surgeons committing errors. Okay, always there is a possibility. But a machines, when you give this job, you do it very precisely, accurately. We can always perform any kind of surgery without of much risk. Okay, that's one point advantages for us. Okay, you can think about surgical robots is coming up really. Okay, so this we have heard of numerically controlled NC machines. Okay, we have a kind of facility available, numerically controlled machines at SASTRA. It's called Shanmuga 4G. I thought of taking you guys there. Once you come over after COVID, maybe you can go there and see some of the facilities. Semi-automatic machines, automatic production line, automatized work cell, all these are happening. These are some old technologies. Think about all this. It's a kind of robotics tomorrow. In fact, this is a very, very famous movie. I recall this movie, starting with yes. What is this movie?
Star Wars.
Yeah, Star Wars. But now it's updated to Interstellar. Have you seen the movie Interstellar in this class? Anyone?
Yes, sir.
If
Yes,
you're
sir.
not seen this,
Yes, sir.
you have to see this movie. Okay. You can see the kind of robot it helps human beings, more like a companion.
Yes, sir.
Okay, for the human beings to take some very complex decisions, fast, accurate decisions. Number crunching job, okay, computing some numbers and telling what to do, more like an assistant. Okay. Another area I think of robots assisting human beings. It's called assistive robots. Particularly for people who are little handicapped, na? So elderly people, handicapped. Assistive robots is really a domain we should look at and help people. Okay, let's think of that. This is what I am saying. Cognitive systems. So cognitive systems, something related to AI-based systems. Okay? That perceive, understand, learn, and develop. That's the key to individual or social interaction with their environment. Okay, this is another area of research, social robots. See how social robots are really coming up and study them. Can you guess some examples for social robots? Some examples for social robots, where it can be employed. In society, where it can be employed.
Sir, like in recent, due to COVID,
Yeah,
in here in government hospital, they have employed a robot, helping
yeah,
robot.
excellent. So why it's called social robots, huh? What do you call it as social robots?
Like, for you're asking this one, sir, this
Yeah, why it is called a social? For
because it
social,
is helping. It is forming as a bridge between doctor and patients. It is I mean, reducing the risk of a doctor going frequently to meet a patient.
yeah, that's why it's called social primarily because it interacts with the human beings. Okay, it interacts and understands the needs of human beings. Particularly in Japan, if you look at Japan, the population is in fact coming down. Okay, huge schools they are now closing down. Okay, big schools is closing down primarily because the population has come down and elderly people numbers are increased. Okay, so they are unable to get people to look after elderly people because the younger population is very going down. Okay, naturally they employ robots. So the robots will look after these elderly people. They understand their emotions and they will take care of their needs. And all these service jobs it's performed. It's a kind of one social robots. Social robots are also can be employed for museum. In museums, in fact, the robots can take you inside the museum and show you places. Particularly society and needs. Okay, that's the idea. Okay, so you need to the robot has to interact with the human beings, understand their needs, and work along with them. Cooperative manner. In a cooperative way, it works along. It's a power. Okay, so that's the idea. Okay, so the main challenges are the cognitive systems have to learn from experiences. That's where the ML technology, DL technology is coming up. So you'll be learning this in second semester and third semester, machine learning, deep learning. There you talk about this learning aspect, completely learn about it. The robustness issues is another problem. Still, performance should not degrade. But with unexpected events, the machine's intelligence will be tested. Human beings, we have that ability to adapt to changing environment. But to create an adaptive machine is a very difficult task. Okay. For example, if I show you one particular image and train my system to recognize this image, and if I slightly modify that image, even by few pixels, if I change that image, the machine may not recognize that. Okay, that is a problem. Okay, so that kind of problem you can address for your research. Yeah, ML, DL domain, computer vision applications. You can study this kind of robustness issues. Okay. Effectiveness should be improved because a cognitive system can predict or anticipate what might happen. And then naturalness. Without the robots should not be what you call an odd man out among us. It should mingle among with us. We should not feel its presence. That's the kind of naturalness we are talking about. Okay? We should not get a feel that a robot is doing a surgery to me. It's more like a doctor. So we should get the feel. So that kind of reliability, that naturalness is another challenge that we need to address. For example, an elderly person may not like a robot to come near to him and perform some services. Okay, because he thinks that it is an idiot machine. So he may not like it. Okay, so we have to create a naturalness. So that's people are working on it. Okay, so these are all some of the melting pot of different disciplines that you can see in this domain: artificial intelligence, computer vision, natural language processing. Natural language processing. What do you mean by it? Anybody from the class? Speech, okay, text, okay, and all these kinds of natural language can process and help the machine to learn from it. Robotics, it's a melting pot. All these disciplines are coming together for creating a cognitive machine. So in our course, we are more concentrating on artificial intelligence, computer vision, basics of robot, some basics of natural language processing, and we are not into neurosciences. Uh, then some mechanical aspects we are handling, mathematics we are handling, some software development is also. Psychology we are not dealing with, philosophy we are not. Philosophy always you can do. Okay. So with that, I will wind up today's class. So there's an integration and embodiment of all these different domains. What this area is all about. So these slides, in fact, I was got inspired and taken from backlog Lavak. Okay, it's a Czech Technical University in Prague. You can visit his website. This professor has written some books also. You can visit his website and get the kind of he has given a lot of materials, sources for to download and to use for academic purpose. Maybe you can see his website also. Okay, so with that I'll wind up today's. Anything you want to discuss now? Any one topic? Something you would like to talk about for another 3 minutes time. Okay, we'll wind up now to discuss. We'll see tomorrow. We'll take up the dynamics issues to start with. I give a brief idea. Then we'll get into the kinematics problem, which is the focus of the first unit. Okay, gradually we'll get into. Okay, we'll go in a very steady manner.
Sure, sir. Thank you very much.
Thank you.
Thank you so much,
Thank you,
sir.
sir. Thank you, sir.
Thank you, sir.